All right, so we learned a little bit about probability. Let's finish up those notes with part 2 of probability notes, 10.1. All right, so number 1, I have a wheel of numbers. Well, again, that probability that we need, we always need the total amount that it could have. Okay, well, in my number of circles, how many total possibilities do I have, or how many total numbers could I land on? Well, in this case, I have 8 total possibilities. Or 8 total outcomes. Okay, so we want to know what is the probability that I spin a 2. In my picture of my wheel, right here, how many 2s do I see? I only see one. I see one number 2. If we remember from the last video, it's my total over my possible. Okay, my total always goes on the bottom, so in this case, the total outcomes that I could have is 8. I only see 1, 2. Well, again, if I can simplify my fractions, simplify it. These are very similar to ratios, okay? In this case, I cannot simplify my fraction, but I can plug it into my calculator to get a decimal, and I get 0.13. Okay, let's talk about a multiple of 2, if I spin a multiple of 2. Well, multiples of 2 are a number that can be divided by 2 nice, neat, evenly. Okay, so I'm going to write my fraction bar for a second. I know that my total always goes on the bottom, which is 8. Now let's go back to my wheel. Let's go through the numbers. 1 divided by 2 does not give me a nice, neat number. 2 divided by 2 does work. I get 1. 3 divided by 2 does not give me a nice, neat number. 4 divided by 2 gives me 2. That works. 5 divided by 2 does not give me a nice, neat number. 6 divided by 2 gives me 3. That one works. Then I have 7 divided by 2, not a nice, neat number. And then 8 divided by 2, which gives me 4. So in this case, I have 4 total possibilities. Can I reduce that fraction? Yes, I can. I get 1/2, which is 0.50. These are both answers I would accept. So either one, give me a fraction in the most simple form that you can get it in, or give me that a decimal with 2 numbers after that decimal. Okay. All right, next one. What is the probability that I spin an odd number? Okay, let's erase this board. Well, we know 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even, 7 is odd, 8 is even. So again, I need my fraction bar. 8, in this case, I circled 4, or highlighted 4 numbers. Again, that reduces to 1/2, which equals 0.50. So half of the time, I'll get a multiple of 2. Half of the time, I'll get an odd number. Let's move on to example 2. So I have 12 boys and 18 girls in class. What is the probability of choosing a girl? What is the probability of choosing a boy? Okay, well again, in order to start any of this, I always need that total amount. Okay, well, I have 12 boys and 18 girls. In total, how many people do I have in that class? Well, how do I get that? Well, I gotta add them up. In this case, when I add 12 and 18, I get 30 total. Again, total always goes on the bottom. So I'm going to actually set up both of these real quick. Okay, what is the probability of choosing a girl? Well, how many girls do I have in the class? Well, in this case, I have 18. Can I reduce that fraction? Absolutely, I can. If I divide by 6, I get 3 over 5. Plug that in, 0.60. These, either one, I would accept either of those answers. Let's talk about the probability of choosing a boy. All right. Well, how many boys do I have in the class? I have 12. Okay, so if I were to randomly choose some random student and within a class that has 12 boys and 18 girls, the probability of me choosing a boy, I have 12 options. over the total, which is 30. I can reduce this fraction. I get 2 over 5. Again, if I divide by 6, put that in my calculator, 0.40. Now, if you notice these two numbers, 0.6 and 0.4, if I add those together, I should get 100. Okay, this is different from the previous problem we did because I have 3 different ones, but we won't worry too much about that. Okay, in this particular, in example 2, this case it does work. Okay, number 3 gets a little more complicated. So I have, in 3 fair coin tosses, how many possible outcomes are there? Okay, so actually I have 1 coin that I'm tossing. I'm tossing it 3 times. So I'm flipping it 3 times. Okay, well, in a coin, how many outcomes do I have? Well, we talked about this earlier in the last video. We have 2 options. I have a tail or a head. So I have 2 options. Let's label H as head and T as tail. Okay, so let's make a little chart here. So I have trial 1, trial 2, and trial 3. So my first trial is I flip the coin once. I either can get heads or tails. I cannot get only tails or only heads. Okay. Then I flip it a second time. That's where it gets a little more challenging. Okay, so if I started with heads initially, and I flip it again, I could either get heads or tails. Okay, well, if I have tails that I started out initially, I could either have heads or tails. All right, then I do it in the last time, so my third time. Okay, so let's say I started off with heads first in my first trial. Let's say I started off with heads in my second trial. My third trial could be heads. It could be tails. I'm not too sure about that. Okay, let's say I had heads first, tails next. I could have heads or tails next. Not too sure yet. Okay, these are all possible outcomes that I could have. All right, in try 1, let's say I had tails first. I could have heads. Well, then my next trial could be heads or tails. Not sure which. Again, if I had tails first, tails second, I could have heads or tails third. Okay, the amount of possible outcomes is actually this last row here. Well, how many numbers do I have? 1, 2, 3, 4, 5, 6, 7, and 8. So in total, I have 8 possible outcomes. This is my final answer. 8 possible outcomes. Okay, let's go back to this dice problem. So I have another regular 6-sided dice. Okay, well, I have a total of 6 sides, so a total of 6 different numbers. Let's write down those numbers. 1, 2, 3, 4, 5, and 6. Okay, what's the possibility that I roll a 5? Again, I always start with that fraction bar. If you haven't guessed it by now, that bottom is going to be 6 because I have 6 total sides, 6 total options. Okay, the probability that I roll a 5. Well, in this number set, how many 5s do I see? I see 1. So actually I only have 1 option. Again, if I can reduce, absolutely reduce to fraction. In this case, I cannot reduce. Plug it into my calculator, 0.17. All right, next one. Again, start off, I'm going to label both of these. 6 is going to go on the bottom because we already know that's the total amount. I'm not changing to a 10-sided die, 12-sided die. I'm always sticking with that 6-sided die. Okay, so what about multiples of 3? What numbers are multiples of 3? 1 is not a multiple of 3. 2 is not a multiple of 3. 3 is a multiple of 3. 4, no. 5, no. 6, yes. So I have 2. 3 and 6 are my two options. Reduce 1 over 3, which gives me 0.33. And then my last one, an even number. If I look at the set of numbers that I have, well, how many of them are even? How many numbers do I have are even? 2 is even, 4 is even, and 6 is even. So I have 3 total even numbers within that set. I can reduce that fraction. I get 1 over 2, which gives me 0.50. All right, let's talk about number 4. So a bag contains 5 red marbles, 4 green marbles, and 8 blue marbles. In order for me to start any of these problems, I need the total amount that I could possibly have. Well, I'm going to add those up. How many marbles do I have? So I have 5, 4, and 8. If I add those up, I get 17 total marbles that I could pull from. Okay, so let's start off with that fraction bar and all of these, because I know I'm going to be looking at those fraction bars. Well, the total goes on the bottom. Total we found out was 17. Keep that on the bottom. Okay, what's the probability that I choose a blue marble? Well, how many blue marbles out of the 17 do I have? I have 8. Plug that in. I cannot reduce this in this case, but I can simplify. I get 0.47. Let's talk about B. I choose a red marble. I have 5 possible red marbles. Again, I can't reduce that, but I can plug it into my calculator. I get 0.29. Hopefully these are getting a little bit easier as we go along. Again, the total just stays on the bottom. The possible outcomes that I could have would go on top. And then C. What is the probability that I choose a green marble? I have 4 total green marbles. And then my total number of marbles is 17. I cannot simplify, but I can plug this into my calculator. I get 0.24. Why don't you guys pause this video, take a minute, try number 5. Hopefully you tried it by now. Let's talk about number 5. So in a standard deck of cards, find a whole bunch of probabilities. Okay, so let's talk about a standard deck of cards. How many total cards do I have in a standard deck of cards? We did talk about this in the previous video. If you remember, I have 52 total cards. And if it's easier, maybe have a picture of what we did last time, just of the set of cards. All right, so I'm going to actually start off with all of these fraction bars, because I know I'm finding the probability of something. Okay, if you haven't guessed by now, 52 goes on the bottom. Hopefully we know that, because that's the total amount that I could have. So 52 should be on all the bottoms. Okay, I randomly draw a 7. Well, how many 7s do I have in a deck of cards? If we remember from that picture from yesterday, or hopefully you have it out in front of you, I have 4 7s within a deck. Okay, well, I can't simplify this fraction. I have 1 over 13, which simplifies to 0.08. Let's talk about B. The probability that I randomly draw a 4 or a 5. Okay, well, how many 4s do I have in a deck? I have 4 4s, And how many 5s do I have? Well, I have 4 5s. In total, 4 4s, 4 5s, I have 8 possible cards. Okay. Again, I can simplify this fraction. I get 2 over 13. That gives me 0.15. Okay, and then see, I randomly draw a black card. Well, if we go back, think about, hopefully you have that deck in front of you. How many black cards do we have? Those are typically the spades and the clubs. Okay. I actually have 26 black cards. Black cards. I also have 26 reds, if we remember from the last video. So 26 is the possible amount. 52 is my total. This can reduce to 1 over 2, which gives me 0.50. All right. Randomly draw a club. So a club was one of the suits. So I have diamonds, hearts, spades, and clubs. We did find this out yesterday in that video. We have 13 total clubs. So 13 possibilities. This reduces to 1/4, which gives me 0.25. Okay, last but not least, I randomly draw a king of hearts. So I'm looking for a king. I have 4 options, but a king of hearts. I actually only have 1 option. I only have 1 king with the suit of a heart. Okay, so I have 1 king of hearts. In this case, I cannot reduce my fraction, but I can plug it into my calculator. 0.02. Okay, we were able to find the probability of a couple different scenarios, make sure we're doing our exit slips, and then just turning them in as we move along.